So now that we have our physical design, our the entity relation model, and we have used the normalization process to make it simple and elegant, it's time to start our physical design and actually creating the relational database. Physical design is a relational modeling process. It's not related to entity relationship model. You can have something designed outside of entity relationship model, but still applicable to physical design. But the good thing about it is that both entity and the relationship are relations. So they follow the same design process. Same design principles can apply to other non-entity relationship model relational designs. Still, entity relationship model is the most popular relational model. So we will not talk about any other model in this class. Relational database is designed to best represent relational models. That's the fundamental easiness. This is where this all easiness comes from. Fundamentally, relations are directly mapped to two-dimensional tables in relational database. And distinct instance of a relationship will be converted to row. One row for each instance in the table. Each row represents a distinct instance of a relation. An attribute of a relation equals to the columns of rows, columns of the table. Each column represents an attribute of a relation. In the relational database, all tables are two-dimensional. Each table is a set of rows with the same columns, and each row must be unique. Now, each row must be unique. Duplications provide no information. You have two rows with the same information, same value. What does that mean? It's not going to help you with anything. Now, technically, in SQL, you can, if the table is without the primary key, you can insert two rows with the same value. But this will usually give you confusion. It's not going to give you any new information. So we should try to avoid that. And in fact, we should try always implement some primary key. Each column has its own name and data type, and is the same across all rows. And the column order is fixed for each table. Now, how do you represent relations inside database? For entities, each entity will be converted into one table. And inside the table definition, each attribute of the entity will be mapped into a column, apparently with a proper data type assigned and the primary key and other constraints applied. For each relationship will also be converted into, or mapped into a table. The relationship should have the keys of both entities of that relationship and the relationship attributes as the columns. Now, if the relationship table has a one-to-many relationship, then usually it can be merged to the many side. The functional determined entity table means the many side. For example, if you have a department course relationship, this relationship basically is a course and a department. You can, instead of creating a new table of this relationship, you can append a department column to the course table. So each course only have one department, right? Then you can append that course column, that department column to the course table. Each course have a department, each course have a department, so on and so forth. You do not need to create a table, separate table for this one-to-many relationship. Of course, you can create it. There's nothing wrong about it. But usually, we will move this one-to-many relationship to the many side, to the functionally determinant entity table side. Because if you put everything inside one table, the performance is better. You don't need to read two tables and putting them together. You only need to do one table read to get both the M side, the course information, and the course department relationship. Okay.